All right, we're on week 4. Anyone have any questions about what we've talked about so far, what you've learned? It is week 4, right? Yeah, because we just finished week 3. Yeah. It's all a blur. Any questions about the work we've done, the coding, the exercise, the labs?
Yeah, I am a little unclear on the one example exercise that we went through here. It's the one that talks about, I think it's the two cities in the addresses in the same cities.
Okay, I know what you're talking about.
The very end, I have to pull it up. It says something like, this address is less than this address. I don't really understand that.
Yeah, I'll get you. Hang on one second. I'll pull that one up for you. I really need to make a note on week 3 to talk about this one because everyone has questions on it when it comes to week 4 because it's a weird question. Let's see, week 3 exercises. Week 4 exercises. There we are.
I sent it in chat in case.
I'm gonna pull up the question from the exercise itself. Actually, let me take a look at it in chat because chats. Oh, was this? This is week 4. This isn't week 3. Is this? This
Yeah,
is
this is week 4.
Oh, okay. Okay. No. I mean, the question he put in the chat is from the week 4 exercises, not the week 3. Okay. All right. That's not what I'm just doing. Okay. Okay. So let me share my screen here. Okay, I will address this one. Screen share. There it is. All right. There we are. All right. Let's close this out. Close that out. All right. Okay. This is not what I want either. This is what I want. That's okay. All right. Now I wonder. I don't have that one here. Let me get in here. Yeah, this example you have here is why would you have a table join itself? Okay, so let's back up a minute before we get to that one. So does anyone have any other questions on weeks 1 through 3 on the code that we've done there? Because this week we're going to talk about joins. Oh, I got to fire up MS Paint or this isn't going to work. Hang on a second. MS Paint. All right. Yeah. You know it's going to be a good class when MS Paint gets brought out. Okay. Any other questions on weeks 1 through 3? All right. Maya, I'm watching your little ones just walk around the background. It's the funniest thing. Just wander around. Don't mind me.
They're crazy.
Yeah, they never change. They're always crazy. I got them up to 21 now, and they're just as crazy when they were 3.
Yeah, they're 3.5 and 2.
It's a good age. All right. So today we talk about joins, and I love joins. Joins are fun. Joins are the bread and butter of what we do. This is how we get the information out because As we said, this is an RMDBS, a relational database model. We have multiple tables in our database. We don't have one Excel spreadsheet that has every column known to man that goes to like column GGG and have to figure out where everything is. We've got a table for everything. We've got to have some way to get the information out from between the tables. And we've got joins. We've got two kinds of joins. We've got inner joins and we've got outer joins. Now, we will talk about cross joins. And we'll talk about some other joins. The only two joins that once you graduate this class that you have to care about are inner joins and outer joins. No one uses cross joins. Unions are cute. They're parlor tricks, but no one cares. And intersect doesn't work in MySQL. So don't try to use it. There will be questions about intersect. It doesn't work in MySQL. There's no except doesn't work. I think it's expect. There's one of the command that doesn't work in MySQL. Anyway. So joins. So who here remembers the good old days of second grade when we talked about Venn diagrams? Remember those Venn diagrams? Ah, Jason's smiling. He has fond memories of the Venn diagrams. Okay. So Venn diagrams. There we go. There's one. And there. Is it coming back to everybody now? Okay. Venn diagrams, when you have these two circles and you've got circle A and circle B, and then you got where they meet in here. Okay. Let me get my little paint bucket here. And we're gonna this one make that red. And we're gonna make this one blue. And make this yellow. We're gonna go primary Superman colors. Okay. So when we're talking about inner joins, where's my text sheet? So inner joins. Okay. Inner joins are when you take two tables and ask the results to come out, and everything comes from this little area here. It's where everything matches. I only want it if it's in here. If it's here or it's here, I don't care. I want it where it's the same in both tables, or I don't want it to come out. Okay. Inner joins are the intersection of the two circles. Okay. Then we have what's called outer joins. And there's two kinds of outer joins. There's the right outer join. And I want that to be blue, please. Blue. Thank you. I do. And we have left outer.
I got a question.
Sure, go.
Do the tables have to be in the same database?
For the purposes of our discussion in this class, yes. In the real world, they can be wherever. They don't have to be in the same they don't have to be in the same database system. You can connect, you can join tables from MySQL, Oracle, and Microsoft SQL Server in the same commands. But I think we talked about it last week. And I owe you guys sometime between now and week 12 code and how to select things from two different databases. But no, they don't have to. You can even write it, and this is just straight up showing off. If you ever want to try it, I'm not going to try to do it because it's hard from Microsoft SQL Server. It's darn near impossible from Oracle, but you can actually no, we're going to talk about that here. You can actually select from a Excel spreadsheet. You can write queries against Excel spreadsheets and pull them into Oracle, into MySQL. When we did the Oracle server a couple of years ago, we did these things called external tables. And what an external table is, it's basically an Excel spreadsheet that you latch onto the database and pretend it's part of the database. It's not a really healthy way to do things because that file isn't protected and someone can delete it and it blows up your database. But who asked the question about the selecting tables from outside the database?
Yep,
Gabriel,
thank you.
Gabriel,
Yeah.
I'll get that information. I'll get it to you. Okay, so inner joins are when we want the results where the same information exists in both tables. Well, the same information, but when we do a join, we take two tables and link them on a single column. So like if I had I'll show you in a second what that looks like, but I want where the values are the exact same in that column. So if it's in one column, it's in the other, I wanted the same one. A right outer join is when I want everything that's in this table and only the things that match from this table. So it'd be the blue and the yellow. Okay. And a left outer join is when I want everything in the red and the yellow. So this is the left outer join. Now, when you're writing this code, we'll look at it. Do I have any left and right outer joins this week? I think I'm just doing inner joins. Yeah. We'll do outer joins, the outer joins next week. But when I'm writing, hello, there you go. When I'm writing the inner join, whichever table I mention first is the left side. Whichever table I mention second is the right side. Okay. And we'll see those in the queries, but this is the basics of joins. It gets complicated. You can join multiple tables, and you will. But yeah, so inner join is when everything's the same. Right outer join is when the right table, we get everything in the right table and only what matches from the left table. And left outer join is we get everything from the left table, only what matches from the right table. So let's look at some code here. So the first thing we're gonna do is union. So when you look at this, I'm selecting first name and last name from actor, and I'm making a union between first and the customer table, first name and last name from customer. So what this is going to do is it's going to take both sets of results and put them in the same table. But it's not going to make any sense. It's bad data because I've got it coming from customer, I've got it coming from actor. There's no rhyme or reason to this. Okay, so, and here I am. I don't know which is from which table, but I can join two tables, the results of them, into one result, okay, with the union. The criteria is it must have the same amount of columns, okay, and any modifiers like the order by has to be at the end. Now, when you look at this one, select first name, last name from actor, where last name is Davis, union all, select first name, last name from customer, last name is Davis, order by last name. So let's look at this one. So this one, I get Jennifer Davis, Susan Davis, Susan Davis, Jennifer Davis, right? It's because I used union all. I'll show you the difference. If I just do union, this is the difference. Okay. If I just do union, it gives me the unique combinations. So I'm not going to, when I did union all, it showed me everything. It showed me both Jennifer Davis, both Susan Davises, right? In this, if I do union, it's going to show me the ones that exactly match with no duplicates. Union all gives me everything. Okay. Oh, I did that. Except it doesn't work. Okay. So here, let's look at this one. So union just is a way to quickly join results from two queries into one table as long as they've got the same amount of columns. If you don't have the same amount of columns, you get an error. And this is one of the rare times where the error statement makes perfect sense. It says the use selected statements have different number of columns. Okay. But what I can do, and I think this is right.
Good question.
Yeah.
What about the column names? Do they have to be the same for both tables?
Nope.
Okay.
See what I just did? This had 3 columns, first name, last update. And this had first name, last name, and email. It had 3 columns. It doesn't care.
Okay.
So here, this looks right, but then we got this. We got 3 dates and an email address. So yeah, so it doesn't, the names don't matter, the data types don't matter. All that matters is you have the same amount of columns in the select queries. That's all that matters. You're doing good here, you're on top of your game. You're ahead of me. I like that. Okay, let's look at this one. This is these are super fancy inner joins here. Okay. So here, there's a couple things about this anatomy of these. So I've got my from statement from actor, and I've got my film actor over here, right? You notice I have the letter A behind this and the letter FA behind this. Those are aliases. What I'm doing here is I'm selecting last name and title and rating from a bunch of different tables. I need to qualify in my select statement which table it's coming from. So here, select A last name. I look here, it's from my actor table because I use the A here. By putting the A here, it allows me to put the A here and not have to type out the word actor. If I don't alias the table, I've got to do that. And that's a whole lot of typing. We want to keep our lives easy. So we want to alias the table. Select A.
Sorry.
Go ahead.
So if you put the A, do you need, like in the from actor A, do you still need actor before the A or just A?
Yes. You have, yeah, in this from statement here, you've got to have the name of the table. So it's from actor, and from now on, it's like, you know, when you're like reading like legal documents and it says like the said defendant William Riker, then like in parentheses, like it'll like give an alias. Like we're gonna call him Bob now. So whenever it's the word Bob, we know we're talking about William Riker, right?
Yeah.
So here's the same thing. From actor A, I know that whenever I see this letter A on its own in front of something, it's referring back to actor. And I have to have the table there to refer back to.
Okay.
Teacher.
Yeah.
Teacher. Also, because from runs before select, then that is why, even though it is in here in what we have in this set of the different words we have here written, the from the second line is going to be run before the first one. So it's taking the A instead of the actor whole word, so we can use it.
Yeah.
Sorry.
Yeah, exactly right. Because I said from actor A here, and this here is gonna be the first thing that's actually this whole thing's gonna be, all this is gonna be run first, because this is actually, this entire thing is the from clause. So this runs at the same time. This is executed first. So in the memory of the query, it knows actor is now known as A, and film actor is known as FA, and film is known as F. So we've got to have the name of the table and then what we want to refer to here. So here at A last name, so I'm getting the actor's last name, F title, I'm getting the title from film, and the rating from film. Notice I'm not pulling anything from the table of film actor in my select statement. I don't have to. The reason I need it, though, if I look at the actors table, I've got actor ID, first name, last update. I don't have any ties to the film table. Nothing in the actor table ties me to the film table. And if I look at the film table, I've got film ID, title, description, release year, a bunch of other things, but no column in here ties me to the actor table. So these two can't talk to each other because I've got no columns in common at all. That's why I've got the film actors table. The reason is because when we talk about, you got one-to-many relationships and many-to-many relationships. You have one-to-one relationships, one-to-many relationships, and many-to-many relationships. Many-to-many relationships are evil. We never use them. We don't want them. They're bad for business. Okay. When you look at the actor table and the film table, one actor can be in many films, and one film can have many actors, which means these two tables on their own are many-to-many relationships. Okay, so I can't put film ID in the actor table because I could have, the actor could be many films. I don't want film 1, film 2, film 3, film, where do I stop, right? And I can't have actor ID in the film table. It's the same problem. How many actor ID to put in there? 1, 50, 35, 112. Instead, I've got a table called film actor. And film actor has 3 columns: actor ID, film ID, and last update. So this table, film actor, connects actor to film. And if I were just look at, if I were just to select from film actor, oh, it would help if I put the star there. Sorry. If I do select star from film actor, all I'm going to get is this. So actor ID number 1 has been in all these movies. Actor ID 2 has been in all these movies. Actor ID 3 has been in all these movies. Okay. So that's how I make that connection. So now, because I want to see what actor was in what film, I've got to link it through the film actor table. So when I run this, I have all the movies that last name that actor was in. Okay. So since this is a Trinity join, you have 3 tables there. This Venn diagram circles gets a little confusing. But so here's the same thing. I got select last name, title, rating from actor as A, film actor, but here I just had a where clause. Okay. And that limits to what I have. Wonder why I did this.
So that filters all the movies just by those that are rating MC-17.
Right. Now notice here I was bad. I didn't put the qualifier here. I didn't put the F dot rating here. So, and I really need to fix that. Now, the trick about adding the alias to the table name, to the column name, technically you don't have to do it if the column is unique to the table. So because last name doesn't exist anywhere else, and title doesn't exist anywhere else, and rating doesn't exist anywhere else, I don't have to add those there, okay? But it's best practice to do that. That way, when you're looking at the query, you know what table they come from, you don't have to guess. If you have, I'll have to show you a query later where you have to do it. But if you did, let's say if you were trying to join customer and actor by last name or something like that, and you're using last name with customer and actor, and you didn't qualify which one you were using. Let's do this way. Let's see if I can write this query. Select last name, B dot first name. Actor A, inner join customer B on A dot last name equals B dot last name. Okay. If I run this query, it should error. Yeah. And here it says column last name in field list is ambiguous because this exists in both tables and we're not telling which one specifically to use. That's why it doesn't know what's going on. I left that one's ambiguous. If I go back here and I take these away, and I run this query, it's going to run fine because these columns aren't ambiguous. But if I try to run this where the last name exists in both tables, it's going to say, and it's another one of those. It's so you all don't know how great this is, but generally speaking, error messages aren't this clear and concise. Okay. Any questions on this? Everyone got the basics of joins? The best way to learn joins is just to play with them. And the queries this week and the next 3 weeks are all about how to write joins. So let's talk about this one really quick. Why would you have a table join itself? So the best example I've ever given on why a table has to join itself, and I've always meant to design this. Let me design this right now. Okay, so let's see if I can do this. Create table dog. And column 1 is going to be dog ID. And it's going to be an int. Dog ID. It's going to be an int. And we're going to get a primary key. Okay. And then we're going to do dog name. Dog. You know, let's just do this here. Let's do this here instead. Let's be fancier. New model. Save, that's fine. I was gonna make that. We're gonna call this one shoes. So here. I was gonna do it for a minute, but I want to finally do this because I want to give you guys a good example on why you would join a table to itself. So I'm gonna create a table here. And this is so just so you know, we're kind of going out of the world of inner joins into the world of how to design a database. We are going to have a dog breeding, ethically not evil farm. This is where all the dogs are happy and we make the baby dogs and we sell the baby dogs, but we're very ethical and everyone's happy and there's no problem. So no one needs to protest us. Okay, so we're not a puppy mill. I had to qualify that. Okay, so let me go ahead and add a table here. Okay, so this table here we're going to call dog. And we are going to have the dog ID and its primary key not null will be int sure. We'll call this one dog name. And that's gonna be varchar, make that not null because every dog needs a name. And then we're gonna do breed. And that's gonna be not null because every dog needs a breed. And then we're gonna have dog mom. And then we're gonna have dog dad. Okay. Okay. So since I'm doing a dog breeding company, I own the mom and I own the dad, as well as owning the actual dog, right? So if I'm doing a select statement to get the information on this, so this is the table we're looking at here, right? So I wish I could do this. So what I'm gonna do is I'm gonna do select a dot name as baby dog. B dot name as mama dog. And C dot name as papa dog. Right? And then I'm gonna do from dog A inner join dog B on a dot dog ID equals B dot dog mom. Inner join A dot dog ID. And draw dog C. What I call that one? Dad dog? Dog dad or dog mom, dog dog. Okay. Do you see why you would join them together at this point? Join the same table to itself? Because in my table here, I've got the dog mom and the dog dad as IDs. Oh, these are ints. So I've got dog dad referring back to dog ID and dog mom referring back to dog ID because that's where I get the IDs from since I own them, right? So here, if I were to query, I want to get the information on it, the dad dog's name and the mom dog's name and the baby dog's name. This is the query I've got to write. I'm joining dog to dog, where the ID, AID equals the BID, which is the dog mom ID, right? So where this ID is the same, it's going to come there. And then same thing with here. And it's going to show me the names of the dogs that are related. Does that make sense? This is a very confusing way to do it, right? So there are times like in this case here, you're joining the address table to itself because you want to find what addresses are in the same city, but aren't the same address. That's what this is saying. The query is, show me what addresses are in the same city, just where the addresses aren't the same. And that's what this is doing. You're getting address 1 from address table and address 2 from address table, where the cities are the same, but the address is different. That's why the results come out this way, because the cities are the same, but the addresses are different. Okay, so these are both in city ID 300, and these are the two addresses in city 300. This is city ID 560. This would be helpful if we just did city name. With the city names on the address table, is it? Now it's in this table here. Yeah, we have to go to the city table. That would confuse things. So that's what we're just trying to do. We want name, we want the city ID and addresses that are the same. They're in both the city, but not the same. That's what this is.
So the less than sign is just saying they're not equal.
Yeah, basically. It's greater than, it's still an inequality. I mean, I think this should work just as well. Yeah, now we get more. So in this one, it was greater than. So it's showing me, since that was greater than that, this one didn't show up last time because this isn't greater than that. Oh, I see. Oh, see what's happening here. So this, if I do, but the not equal to, if I do this in here.
Yeah, 23 is
yeah.
not the same as
Yeah.
47
But
versus 47 is not the same as 23.
Right, but I've got 4 here, right? So they're
Yeah.
showing me, so if I do this, where it's just not equal, I now have 8, because this one and this one are the same. This one and this one are the same. This one, they're just in a different order. So so you see how I'm doubling up. If I say this way, it's just give me one set of them and not 2 sets of the same thing. Okay. So this is just saying, show me the addresses, show me both 2 addresses that are in the same city, but they're not the same address. This one is showing, give me the name of the dog's mother's name, and the dog's father's name. And this is how I know I have to join everything together. So I'm gonna go, so does everyone kind of get why you would join the tables together? Join the same table to itself. Okay, so I'm gonna jump back over here to this diagram here. Okay, so I'm gonna get rid of these columns because this is bad. I don't like this at all. So I want to get rid of that column. And I get rid of this column. Okay. So I've got, I'm just going to this column really close, please. Oops. Okay. So there. Okay, so we've got dog ID, dog name, and dog breed. Now, what I'm going to do here is, if I don't want to do the multiple joins, I've got to add tables here. So I gotta put here, I gotta put gender, because that's important. And there will be a char1. Char1. Okay. And then okay. So I've got ID, dog name, breed, gender, and then I will go and put I'm not gonna say this is all I need here. I think that's all I want for this one. I might do ID. I've got dog ID. Okay, there we go. Oops. Add in columns here. Delete selected. Delete selected. Okay, so then now I got a couple of choices here. Oh, under here, color. Color's good. Okay. Okay. Now, so I have a choice here. So I've got the dog breed here, right? So I theoretically could just type that in and let it be like, you know, Dachshund, Cocker Spaniel, stuff like that, right? But what I'm actually going to do is I'm going to create a new table here, and I'm going to call it breeds. Oh, give them a table. There you are. Okay, I'm going to call this table breed. And then here I'm going to do breed ID. And then I'm going to do breed name. Okay. And then what I'm going to do is I'm going to get rid of this breed column here in this table. And then I'm just going to join in the right way. I'm going to join here. Now, why would I do it this way and have a table for breed and use the breed ID over here instead of having a column here that I just type the breed name in? Any guesses as to why I would do that?
I'm sorry, what was your question?
So a second ago, I had a column in here called breed, and I was just able to type the name of the breed in like Cocker Spaniel, Dachshund, right? But I changed it. Now I've got a table called breed. And instead of having the actual name of the breed in here, I have it over in this table and I've linked it over like this. So I just have an ID in here and link it over to this breeding table. So why would I not have the word breed in here and just type in have the word breed, and why would I link it over to a table?
Because there's a lot of breeds.
There are a lot of breeds, but one dog will have one breed, so it's 1-to-1. So it's not many to many, right? So when you're filling out databases, when you're building databases like this, there's a couple of things you got to keep in mind. Number one is we want to keep it normalized, right? We want to make sure the data that's in the table only belongs in the table. And breed is something that belongs in this table. So we totally could have the word breed and type in the word. But the other thing we've got to remember is we want to keep the data sound and complete and have no errors in it, right? So imagine, if you will, the front end of this database where someone is inputting the information for a new dog. Okay. And they get to the breed section, and they have to type in the name of the breed, and they don't know how to spell greyhound, and they spell it wrong, and they put that into the table. That means I've got greyhound spelled 5 times right here and 3 times wrong. So if I'm doing a search for greyhound, I'm only going to get the results based on how I spelled it, right? Imagine that same front end, instead of having a box where they type in the name, there's a drop-down menu where they can choose the breed. Okay. That drop-down menu will be populated by this table. So we will do joins in separate tables sometimes based on the need to keep data untarnished by human hands. Does that make sense? Have I lost anyone on this? I want to take the silences. Everyone is good. Okay. Same thing with color. I could just have a color column in here that anyone type in the color, but I have the same problem. You know, what if they misspell red? What if they make a new color up? Okay. Same thing here. Okay, so then we're going to do this. We're going to hit this little button here and go boom, boom. And now color ID is here.
User input is definitely an area where Murphy's Law applies.
Yep, absolutely. Absolutely. We want to control user input. I had this conversation with my team at work today about mitigating human error. We are an imperfect people, and that's totally cool, but we want to make sure our data is as close to perfect as it can be. But you're absolutely right, Mark. Okay, so now another thing we got about dogs is their traits. So look at the dog here. So they may have a docked tail. So we can put here tail. Okay. Another trait they may have is markings. Another trait they may have is snout. I'm kind of making stuff up here at this point. So I'm trying to think whether I watch enough dog shows to know this. I'm trying to think whether traits they may have. So here's the thing. I could definitely put like tail, markings, snout in here, right? But a couple things happen here. I could make so that with tail, you got like long, docked, short, broken, whatever. And then markings could be party, could be spotted, could be whatever it is there. And then snout, there's long, short, snout, whatever. So there's a couple things by doing this. If I put the traits in here individually, I could make another table like color and breed, right? And add them here and have 3 more tables and have the choice here and the choice here, choice here. But the problem is, let's say we did this and our database is up and running and it's great and we love it and it's happy. And then all of a sudden someone says, hey, we've got a new trait. We need to, oh, here, like something, hey, we need to see if the dog is fixed or not. Right? And I'm sure that's not the appropriate way to put it, but the dog is fixed or not, right? So now, if we do this, we have to change the structure of our table. We have to add a column when a new parameter comes into play, right? So see what I'm doing here? So if all of a sudden we have to now know whether dog's been fixed or not, you know, then we have to change the entire sort of table. Then we have to input data into all those tables. So this gets to be kind of, it's overwhelming to have to change the structure of a table. We want to design our databases to where if we have to make a change in the data that has to be collected, it's as minimal as possible. So what I will do here is I'm going to get rid of these. Delete selected. Delete selected. And I will make a table called traits. And in here, I'll have trait ID.
I have a question.
Go ahead.
When you're like drawing a diagram, when do you use the solid line versus the dotted line?
solid line is 1-to-1. Or 1-to-many. So this is, so I think if we did this, the solid line is a 1-to-1 relationship. That's when you'd use it. What I suggest is just trusting what this does here. I don't know why you would use dotted versus, honestly, I don't know why I use dotted. I just always use the dotted ones.
All right, that is good enough.
Yeah, I
Use
don't
the
think,
dotted one.
yeah, I don't think,
Thank
because
you.
when we extract it to the code, it's not gonna make a difference. So here I've got the trait ID and I've got the trait name, right? We can add description there just for fun. Okay, now one dog can have many traits and one trait can be part of many dogs. So here we've got our many-to-many relationship. So we do this, boom, boom, and it creates the table for us called dog has trait. Okay. So now we have that. So then we can do the same thing with, we can make a table called, nope, just one, thank you. Okay. What else we need about the dogs if we're gonna sell the dog? We need to know whether they've been vaccinated or not. If I can get this to give me the new table, please. Come on, give me my table. There you are. So here, I'll change make a table called vaccine. I'll even spell it right. I'm not sure to spell it right. Vax. There we go. Let's do that. Okay, so here we have a Vax ID. And then Vax name. And then change this to Vax. So here, I'm gonna have a many-to-many relationship because one dog has many vaccinations. One vaccination can happen to many dogs. But I'm gonna make a slight change to this one, do this, boom, there's my table, right? But here I'm gonna add a table column called date. Because we need to know when the dog is vaccinated. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, now I want to know who the dog's parents are.
Do you need an ID for those many-to-many tables?
Excellent question. So let's talk about that for a second. So the purpose of the ID, and let's look at the dog table here, right? The ID is our primary key. Okay, so does anyone know the traits of a primary key? It's unique to the table, and it cannot be repeated, and it can't be null, right? So we are guaranteed that this ID is it's only 1, 2, 3. It's only going to happen the one time there. No other column in this table can meet those criteria. Okay. So, and I look at breed ID, it's the same thing. Now, when we look at dog has trait, you'll notice that primary key has been checked for both columns. Okay. So a primary key has to be unique to the table. So whereas one dog will have many traits and one trait will have many dogs, this dog will only have that one trait one time. This dog will only have this one trait, this one vaccination. Oh, you know what? For this one, that's a good point. So this dog would have a vaccination multiple times. So here for dog has vax, we'll actually have to make a dog vax ID. That was a good catch. Vax ID. And then we'll uncheck these and put that there. There we go. I've never done a dog table like this before, so this is a new one for me. Okay, so here, one dog will only ever have one trait, and the dog doesn't have two tails. So I can do this, and I can make this the primary key. So these two in turn would keep the entry, the row unique, so you wouldn't need an ID column. Dog has vaccine, on the other hand, this one dog would have this one vaccination multiple times. So this would never be, these two together wouldn't be unique because the dog has a rabies vaccine every 3 years. So I'd have to make an ID column there to keep it unique. Okay. I don't need an ID column if I've got two columns that I can make the ID column with unique value, like this one. This one, I have to have an ID column because these two columns won't ever be unique enough for me to keep it the same. I could theoretically add date into the, I could do this one. I could do this. This is also the part where I kind of ramble on. So if anyone gets confused, stop me immediately. I could theoretically add date to that. Sorry, I can make this the primary key. So these three columns together would be the prime. What's going on here? You go away. You go away. So I can do this. Okay. I can take these three columns and make them unique and make this the primary key. So before, just these two were the primary key, but they weren't unique enough because there'd be multiple entries of one dog's vaccination. But if I add the date there, that becomes unique. So the dog will get vaccinated on a specific date and that will never repeat. So you don't need an ID column here either. Did that confuse your question, Gabriel?
Oh, that makes a lot of sense.
Does
As
it make
long
sense?
as,
Okay.
as long as we have the date not null, right? So they
Yep.
have to
Yep.
force to input something. All right, that makes sense.
I'm glad because I was worried I confused a lot of people. I'm sure I confused at least one of you. Okay, so we've got the dog and we got the color of the dog, got the breed of the dog, we got the dog traits, we got the vaccination history of the dog. I now want to know who the dog's parents are, but I don't want to have a dog. I don't want the columns in here to refer to itself. I'm going to do. So we can do this a couple of ways. Let's try this way here. Let's see how this one plays out. So I'm going to do dog as mom. Oh, let me explain something here really quick. These relationships here that I'm drawing here, these are foreign key relationships. Okay. So what a foreign key relationship is, since it's going this way, right? So this is the main table, this is where the foreign key lives, this is the main table, this foreign key lives, these here. So if it doesn't exist in here, it can't exist in here. So if I've got colors like 1 through 12, right? And someone tries to put 13 in here, it's not going to work. If I've got breed IDs 1 through 12 and someone tries to put 13 here, it's not going to work. When we foreign key things, we're ensuring data consistency. So data can't go in here, that's not in here. Data can't go in here, that's not in these two tables. Data can't go in here, that's not in these two tables. Okay. So here I'm going to do dog ID. I'm going to do mom ID. And what I'm going to do, okay, is I am going to do this. That goes there. And then, actually, this is going to be 1-to-1. Yeah. So I'm going to do 1-to-1. That goes there as a 1-to-1. Wrong way. Did not want to do it that way. So That's to there. Nope, still the wrong way. So that to there, that's what I wanted. Okay. I don't think this is gonna work that I want to, so let's do this. And do this. That to there. Okay. So I want to make this and get this one here. So here. Get rid of you. Get rid of you. And this is going to be dog ID. And then this is going to be mom ID. Okay. So now I've got one table that's foreign key to the same table twice. Let me make some room here. So put you there. And there. Let's put you up there. Okay. That's one way of doing it. That's an interesting way of doing it. So we get the dog ID from here and the mom ID from here. I'm just join. It's a lot cleaner than doing it in here. And I can even do here. And do that, make that the dad ID. And then change this to dog has parents. Okay. Everyone following that? Can anyone see a problem with this? Why I would maybe run into a problem having it this way with dog ID and then mom ID, mom IDs to dog ID and dad IDs to dog ID. So where would I have a problem with this table? Because it's foreign keyed. So it has, if it doesn't exist here, it can't exist here, right? So the dog ID has to be here. So where would I run into a problem with this setup? If I didn't own the mother or the father. So here, these are all not null. So if I don't own the mother or the father, this table is going to error because I can't put it there because it can't be without the dad or the mom. Right. So what I can fix here. So I may not own the mother or father, right? So I'm going to go here and I'm going to add a column owned. And make this a bit. That way I'll know if I own the dog or not. In the binary. Why? Well, that's not fun. There we are. I'll fit. Okay. Okay. I don't know why it's not letting me do that, but that's fine. Just a varchar one. Okay. So I added that so I know if I own the dog or not. That way, if I don't own the dog, it's fine. So if I don't own the mother or father, I can still put their information in here. Did I lose anybody? See, this is kind of what happens when you're designing a database. You just kind of like talk to yourself and go through and see how these tables all need to form out and what you're going to do and how they're going to work through. And I just really like the process. Is everyone kind of seeing how this is coming to life? Give me a thumbs up if you see that this is how this is coming to life.
Yeah, that makes sense.
Yes, yeah. So, and this is generally how, and Jason, you had given me the example about the shoe thing, and that's what I was going to do today, the shoe thing, but then the dog thing took over. Because then you're a reverse engineering, use that shoe thing, and I had the whole thing ready to do the shoe thing, and then now I'm doing the dog thing. But see, so this is how, so when you start with one table going, okay, I need a column for dogs, and this is what I need to know about the dogs, right? And this didn't even get to like who bought the dogs, when they bought the dogs, who works for me, you know? But this is 7, 8 tables, and this would be fine for the purposes of, if you were going to do this for the, if you're going to do a dog breeding database, this would be perfect. 8 tables, because you can add stuff, but you can't just add 2 more tables. Anything I would add like 5 to 10 more tables. Like if I try to do the owners who own the dogs, that would add me at least 3 tables. If I did like employees, that would add another like 4 tables. If I added like, you know, retail locations and salespeople and stuff like that, that would add a bunch of tables as well. So I would pretty much just stop here. So, yeah. Okay. Did everyone kind of see how that flowed out? So we'll probably,
Yes.
so probably next week we'll probably do the shoe thing, because I really had a thing for the shoe thing too. So we'll design the shoe database. Jason reverse engineer a place that sold sneakers, and it was interesting on how that data flowed. I had the whole diagrams in my head. But so yeah, this is how you would do that. This is how you start designing a database. So those of you looking to do the final project, this is kind of what you do. You kind of pick one table to start with, you know, customer, dog, book, anything, and then it just grows from there, you know. And I could probably, if I sat down and thought about it, I could probably add a bunch more stuff here to dog, you know, like country of origin or any number of things. I could add tons of stuff, like, yeah, birth country, there you go. Particularly if I don't own the dog. But yeah,
I have another question.
hit me.
You wanna update the breed? What? Let's say you wanna update the dog name and the breed. You update the data on the dog table, and the breed on the breed table, right?
Well, what do you mean? Like if you're
You wanna
like,
update the data, huh? Yeah, like I mean everything that has inside. Let's say you have like 100 record or something, and you wanna update the name, but also the breed.
why would
So
you
I
update
guess-
100? Well, I guess the question is, why would you update 100 names?
I don't know. Just saying. Like I just wanna understand, if you wanna update, you have to. Where do you update the data? In the dog
Okay,
table
s-
or in the breed table?
So it depends on what you're updating. Let's say, let's say someone entered the name of the breed wrong. Like so someone's been still a greyhound in the breed table. So you'd update the breed table to fix that, right? But let's say someone entered it wrong and there were 22 dogs entered as greyhounds that should have been entered as Rottweilers. So then you'd update the dog table. Let's say let's do this one. So let's say let's add price, sale price, right? Like if I want to change the sale price, like if I want to discount all the dogs 20%, I would say change everything on the dog table. It really all depends what data you're trying to update and what you're trying to actually do. What would be a mass thing here? Let's say like okay, let's say there's you're removing a trait from a dog, then like you just remove it here. Like I said, it depends on what you're trying to change. Yeah, in this case, let me think about that for the next week when I design the database with you guys, when I do the shoe database. So I'm trying to think of where you need to do a massive change that would, where would you do a mass change that would affect, how would you make the mass change? Because this is kind of set up to where you wouldn't have to. You shouldn't have to make massive changes. Like here, if you added a breed, let's say if you started breeding Cocker Spaniels, you would just add them here and then just add them along as you're going along here. So you wouldn't have to do that. If you added a color, you'd add it here and you wouldn't update any existing colors, you just add it new. The parents wouldn't change. Yeah, I'm not quite sure how to answer your question. I'm sorry. Not with this one, not with this setup. I'd have to design a database that would specifically allow that. That would make sense of that. Because you want to set up these tables to where you don't have to make massive updates. Like that would break things. That's why we do. That's why we have breed in a separate table. So we have color in a separate table. Dog traits are over here. Vaccinations are over here. We don't have everything in the one table because then we'd have to do massive changes in the one table. Could you imagine if there's like an Excel spreadsheet and all these columns in the thing, you have to check them off as you go along, you have to add like 10 columns for traits or worse yet, put everything in one column and just like put commas between everything. You know, that's why we don't want to do this stuff. So Gabriel, I'm not really sure how to answer that question. I'm sorry.
No,
I'll-
it's all right. It's all right. I think I
Yeah,
have
I'll
a better understanding now.
yeah,
Another question.
good.
What if you need to like create a new field, a new column? Do you think that it's better to have their own table or just add it to the table that is already created?
So
It's
that's
like I was trying to understand if it's which one is better, or if I have an option, which one should I use?
sometimes, so it depends. So that's a great question. So we kind of talked about that last week, right? When I said we had a customer table and like we designed this database in 1980. And in that table, we've got the customer, we've got name, address, and we got phone number. In 1980, everything was great, right? And then 1990 comes around and everyone's got email addresses. So because of that, we'd have to add a column to the customer table, right? We want to design the database as best we can where we don't have to add columns to tables because that changes the structure. We don't ever want to change the structure if we don't have to. We want to keep this the same. Like I showed you originally, like here in the dog table, I could have put like a column for Greyhound, a column for Cocker Spaniel, and I could have checked the one that it was, right? And I could have had like 13 columns. And then if I added a new breed, I had to add a 14th column. But if I put everything in a breed table, all I'm doing is adding a line of data, and that changes everything. It adds it to where it needs to be added, right? Sometimes you don't have a choice but to alter the structure of a database. And then to your point, like, you know, what would I do? Would I add a column to the dog table? Would I add a new table? It would depend on what I'm doing. So let me look at this for a second. Let's see. So let's say, okay, so let's say I currently have one, I'm gonna call it Daisy Hill Puppy Farm because that's where Snoopy was born. I bet no one knew that. That was where Snoopy came from, Daisy Hill Puppy Farm. So I have Daisy Hill Puppy Farm, like Orlando, but I'm gonna open up Daisy Hill Puppy Farm, Nebraska, just because Nebraska. Okay, so now I need to know which location the dog came from. Okay, so would I add a location table to dog, or would I add a table for location and link that into dog? Which would I do? Which would be the easiest? Which would be the easiest going forward to mitigate any future changes? Adding a location table here, a location here, and let people type in the name, or create a location table and use it to tie in like the breed table does.
Location table.
Yeah, be the location table. Same reason. I don't want people to get confused. So I would say, okay, so in this case, so Gabriel, I would create a new table and call it location. On the table. Let's go. There we are. And I'll create a call location. And that way, right now I just have Nebraska. I might add another one. I might add Wyoming. I might add Indiana. I don't know. I might add Quebec. Things are doing really well. I got Daisy Hill Puppy Farms in Hawaii.
So if you added a second location like that, and you wanted location data in each record, that would be probably one instance where you would go back and add that to all of those that were previously in the database, and a mass update where you would add your first location to all of those dogs that are already in the system.
Thank you for tying that into Gabriel's first question. I appreciate that, Mark. Great job. So yeah, so that's what the case. So if I have location ID and I'm now going to do a relationship here for this, and I do it the right way. Delete selected. So I'm going to add this here. I did it the wrong way again. I'll get this one day. So now location ID here, if I had like 300 dogs here, that column is going to be null, and that's bad. So now I'm going to do mass update to make sure the right ID is there. So Gabriel, there you go. That's answer all your questions. I have to add the column, I have to add the table here for the location, then I have to go update this entire thing to make sure everyone who is born at Daisy Hill, Orlando is listed as Daisy Orlando, and then going forward, it'll be Daisy Hill, Orlando, or Daisy Hill, Nebraska.
Great, thank you.
All right. We are just at about time. So we need some chats here. Oh. Oh, the paper this week. Yeah, I haven't talked about that yet. I'll talk about that real quick. What's the paper this week? Let's find out, shall we? What is the paper this week? Modules. Now, again, if you are doing the final exam, your paper this week is where you're at with your final exam, with your final project. Like a lot of people are like saying, like the papers have been like, hey, I'm going to do this database. What do you think? So that's been it. If you're not, and you're doing this one here, you have had a probable third week at your new company, built your skill on filtering data in and out of the queries result. No, I'm in week 4. And learned how to join multiple tables this week. Your boss gave you a new task. You should qualify what you learned about redundant data in the context of equity. Oh, yeah. So, yeah, equijoin is another way to say inner join. And I don't know why they worded it that way. So just talk about, just so you qualify, learn about redundant data in the context of inner joins, statements, tables, and subqueries and tables. For those of you who are watching the video and are here tonight, just tell me about what you learned about inner joins. Don't worry about anything that this says here. If you're not watching the video, you're going to write this and you're going to struggle. And then we will tell you should have watched the video. So you have no idea when people just don't watch these videos and just answer weird things. So who was that? That was Mariana. If you're still here, are you still here, Mariana? Yeah, you're still here. Okay. So all I want you to do is tell me about inner joins. What did you learn this week about inner joins? And that's it. That's, if you're not doing the final exam on the final project, write me a 3 to 5 paragraph on what you know about inner joins. Okay?
Okay, thank you.
Yeah, no
But,
problem.
I have another question.
Sure.
Last week, we had the final options part in
Yep.
the week, but we didn't have any like thing to submit.
You
saying,
don't.
like, which option.
So
So
is this your first Wednesday with us, or you've been the previous Wednesdays?
I watched it, I think last week.
Okay.
think.
So you don't turn anything on the final, if you're doing the final project, you don't turn anything until week 13. Everything's due on week 13.
Okay, but
Nothing.
then in the papers, I would just talk about the project.
So like if you're doing the final project in today's paper, say, Brother Stevic, I think I want to do a database around dog breeding. It's a passion of mine. I love dogs. I want to make Daisy Hill Puppy Farm, Nebraska, and here's how I'm going to do it. Right. And then over the next couple weeks, say, hey, Brother Stevic, I came up with these 8 tables. Everything's going good. And then week 6 is like, hey, I got a little trouble. I can't figure out how the joins are going to work. So just every week is like a journal entry to me to tell me how you're doing on your project. And I will respond and say, hey, have you thought about this? Have you thought about that? You know, and then I'll say, like, show me your ERD, show me what you got. And then we'll go that way, because that's the way we're going to communicate on how to get the project done.
Okay, I understand. It's because when you explained the first time, I thought the canvas would have changed, like for some reason would change paper for like project.
If I change the well, first of all, I'm not allowed to do that.
Yeah.
Second of all, if I did that, anyone who wasn't on these meetings would get terribly, terribly confused. I've got 3 kinds of people that take this class. I've been doing this class for 7 years now. Person number 1 comes every Wednesday. We talk, we show, we go through the whole thing. They learn the process. Everything's great. The second kind of person who comes like the first 3 Wednesdays and then figures they know everything and just kind of figure they go along and they do okay. The third kind of person who's never comes to a Wednesday and never watches a video, and then they have no idea what's going on. And they just kind of like make it up as they go along. I've got people right now in this class who are up to like week 7 in the work because they're just zipping through it, you know? But I don't think they're getting everything out of it because we're not having conversation. They're not learning. They're not watching the videos. They just want to pass the class. So if I change this to say report on your final project, they would have no clue what we were talking about. So you guys are the elite. You guys are celestial +2. So because you're every week. But yeah. And they don't let me change it, or I would. I would definitely change the quizzes. The week 6 quiz has a lot of weird questions in it that I've got to go take out, or you guys are gonna get really mad because you're not gonna know what everything. You don't know what the VCI interface is, and no one ever talks about it. It's not anything we document in this class, but the questions are there because someone wrote it that way. So, but it's all good. Keeps us on our toes. All right, friends, it is 11:45 here in Florida. So I am going to sign off now, unless there are any other questions. All right, then I will post this. And you are right, the language in the quizzes are pretty different. And some of them are straight up trick questions. There are straight up trick questions that are made to trip you up. That's why they should be set to, I need to double check that they're set that you can take it twice. If they're not, I got to fix that. But you should be able to take them twice. But yeah, just be careful on them. And if you feel like a question is unfair and it was wrong, just let me know and I'll probably just give you credit for it and fix the question later. So the focus of this class really is the Wednesday night meetings, the code, and the final projects. The quizzes and the exercises, well, the exercises are different, but the quizzes are checking boxes that we have to do for accreditation. I'll be straight with you about that. That's the check box for accreditation, which is why we do the video presentation on week 2. That's to keep you from having to do Proctorio. So I'm far more honest than I should be in a lot of things. So, all right, guys, have a great week. Keep in touch if you need anything. Okay.
You have a great week.
You too.
Good
Bye,
night.
guys. Good
Thank you.
night. Bye.
Thank you, teacher.